All right, folks, thank you for joining us for another demo roundup. I don't have my cowgirl hat on today. Left that in my other horse saddle bag. I don't know. Just go with it. With me today, I have Corbin Mills. Corbin, say hello.
Hello.
And we're going to be going through an end-to-end demo that Corbin's put together showing the PagerDuty Operations Cloud as applied to a Kubernetes environment. So before we get started, just some housekeeping items. I'm normally here on Mondays, live streaming at 1 o'clock Pacific, at 4 o'clock in the afternoon Eastern, the Unplanned show. So just to kind of take you through some of the upcoming guests that we do have through the month of August. On Monday, we'll have Martin Vincent talking about platform engineering. Then on August 14th, we'll have James Urquhart from VMware talking about flow architectures. On August 21st, we'll have our very own Senior Director of Data Science, Mitra Goswami, talking about generative AI. And then just booked, I've got Donnie Burkholz coming on August 28th to talk about bridging ITIL and DevOps. So now, one thing just to kind of orient folks today is a lot of folks know PagerDuty usually for kind of, sort of traditional on-call paging. But what you're going to see in the demo that Corbin takes us through is actually really kind of like the full operations cloud. And what do we mean by that? A lot of folks are familiar with, PagerDuty is almost like the first point of entry and integration that a monitoring vendor is going to build. A lot of alert and event data from all kinds of telemetry and instrumentation. And that's not just your monitoring observability. It can also be security tools. We just had Heather Hinton on Monday, so it was great to talk to her about sort of, kind of that orientation around security. It can be your DevOps lifecycle tools, which is really great for capturing all of that change events, since that can often be the point of something that failed or a disruption. And it can be data ops. It can be, Monte Carlo and some of those different systems that are emerging. And this is obviously a hot topic today with the increasing emphasis on AI and really, wanting to embrace building out very sophisticated architectures in order to support using LLMs in production. And then downstream, there's also like, where do we then mobilize folks and activate automations and help teams coordinate in chat systems, and then integrate even with kind of more of your legacy and heritage ticketing systems for kind of your IT operations and those, non-urgent operations. So that's just kind of a quick overview. I'll pull this down and really hand things over to Corbin to take us through. Let me pull up your demo screen here.
Awesome. Thank you, Dormain. Yeah, so today I've got a demo planned for you. I'm going to take you through what it looks like using the PagerDuty Operations Cloud to handle your events, the life cycle of your events, so from beginning to end. And in this case, we're going to be focused on a Kubernetes use case. So without further ado, let's go ahead and get started. I've gone ahead and sent a few different events here into my environment. And we could see here, the PagerDuty platform's already done some work in the back end. So as soon as these events arrive ready for me to consume, we've already done things like set the priority and urgency, which gives us valuable context. Lets us know, what's important, what's not important, and then what I should work on first, right? It also allows me to do some data transformations. So we'll see in a minute here how I was able to actually pull the pod name out of the event body itself and put that inside the incident title. So now, as a responder, when I log in, I've got a lot more context as to what's going on. I know which pod I'm dealing with, as well as knowing that, currently my Kubernetes pod is in a crash loop backoff state. So we're able to give folks a lot more context in that way, so you know more immediately what you're dealing with. As we look, we could see that I've gone ahead and grouped some different alerts. So the first alert that comes in is going to create our incident initially. After that, any alert that comes in that's related, we could see we've got two different kinds here. We're going to go ahead and group them together. So we're not going to create a second alert. We're not going to call, notify and page out to someone again. We're going to allow you to stay focused on dealing with the issue at hand and help reduce the amount of noise that you have. Because let's be honest, a lot of these systems are interconnected. So when something does happen, you're going to end up getting an alert storm with, tens of, if not hundreds of alerts coming in.
My new catchphrase for that, Corbin, is like a disturbance in the force when like thousands of alerts cry out at once and then are silenced.
Exactly.
I don't know. It's a bit of a throwback Star Wars reference, but hopefully people still appreciate those.
Oh no, I like it. I like it. It works, right? Exactly. Yeah, we've got all these disturbances coming in, and we're gonna go ahead and group them for you. We don't lose any fidelity of data, right? I can dive into the details of each of these alert bodies, so we're not losing anything by doing this. We're just consolidating, and again, making things more efficient when you're trying to deal with the issue at hand. The other thing we're going to do, you might not even see, another way we can help reduce noise is through suppression. So it could be a health check came back healthy and we don't care, so we can throw that out. Maybe it was a event from my dev environment and I don't care about that as much, so we can throw that out. Perhaps it was a transient alert. Yeah, it's something that a spike in utilization that comes and goes. We can set it to when they see those types of spikes to wait before we notify folks and try to bring them in. And then if the issue still existed and after a certain amount of time, we can go ahead and page someone. But if it's self-resolved, then we can again close out that incident and we really didn't have to bother anyone. So again, another way that the PagerDuty Operations Cloud is going to help you reduce noise and just remove a lot of the toil and work that we have in our day-to-day lives.
Yeah, particularly given, Kubernetes has that sort of self-healing attribute, right? It's trying to reconcile back to, this is how you've declared you want your environment to look like. So it's doing a lot of that self-healing, and so it sounds really useful to be able to just like hold on, let's pause on that, let's see if this self-resolves before you start waking people up.
Yeah, exactly. And we can ingest all those signals and act accordingly, right? Based on how you've got your rules set. And then probably the final thing we'll talk about, just on this screen here, is where the platform will help you is routing to the right team. So based on what's in the payload, based on what system is impacted, maybe it's the criticality, or if it's a certain application, we want to make sure that this incident gets to the right team as quickly as possible. So that's where the routing that we're going to do across the organization is going to ensure that the right folks are looking at the right incident at the right time. So that way, you don't have to reassign tickets. It doesn't get lost in the queue. We're paging out specifically to the team that should be handling this. So that's kind of the results. We'll take a step here and look a little bit of how this happens. So I'll dive in. A quick overview. As events flow into PagerDuty, we're going to have one or more integration keys. These keys will get set inside of your monitoring tools or your scripts or whatever might happen to be sending us signals. You can have one or more keys, so you can have it divided. But the idea is events will flow through. That key tells us exactly where that event belongs. So we know it belongs here with the cloud and infrastructure applications. After it comes in, we're going to do some global processing. So this is something that happens on all events. Maybe it's setting criticality based on what's in the payload. As we'll see later, it could be some data transformation, where we move data around as we saw in the incident title. After we do our global orchestration, we'll go ahead and hit our service routes. So this is where we're deciding which teams this should be routed to based on the payload and the information that we've received. And then after that, we're going to hit our service orchestrations. So we do additional processing and transformations, but now this is specific to a particular service. And as we dive in, we'll take a look. I've got this service orchestration pulled up. specifically for our Kubernetes environment. We could see once it's routed, there's a few different things I'm going to do automatically. I'm going to start off and run a basic health check, make sure that my Kube API server is up and available, right? If that's not available, any commands that I'm trying to run later on the test certainly aren't going to work. After I've kicked that off, this is where I actually grab the name of the pod and put it at the front of the incident title. We could dive in here. This one's pretty interesting to look at. I'm running this for all events, so we can also set it conditionally when to run. But in this case, I'll run it for all of my events. Here, I'm going to do a transformation. So I'm getting the pod name out of the event details. I'm creating a custom variable here, and then I'm taking that custom variable and putting it right in the front of that incident title. So I keep the original title as well as prepend this additional information. So again, as we saw back on the incident itself, when I log in, I know immediately what I'm dealing with. I've got the insight and context that I need to start making, quick and efficient decisions.
And that I just want to ping on that for a minute, because that's one of those seemingly simple things, which is just pull in the pod name into the incident name. But when you haven't automated that step, then every time there's an incident, like the first person has to go answer that question, and then they have to go digging around in order to figure that out. And it's just such a simple thing. And the other thing I was thinking about is, you're showing this at this is the service level orchestration, but I could also imagine that some of these best practices, like just make sure that, the Kube API is up so that all the other commands we might want to run, like yes, no, or is that even available? Or some other kind of best practices. I almost wonder if some of those would be really good to just set at the global level, especially if you've got a pretty broad deployment of Kubernetes and you have lots of different teams. But the SRE team, for example, who's maybe supporting a lot of different services, and they know they have those best practices, like putting that in at the global level could be a really useful way to just up the game of all the different teams that they're supporting, because all those different development teams just may not be really deep in Kubernetes best practices and may not really realize you need to test that API first to make sure it's even working. So anyways, just thinking out loud as you're walking through this.
Yeah, no, that's a great point. And yeah, the things that we see here, we could certainly be doing a transformation at a global level, right? So, for all of our events, and certainly, yeah, level up those best practices if they apply, across the field and not just to these specific services. While we're here, I'll quickly just click through and show you some of the additional things, right? This is where we came in and set our priority. So we saw that, being set as part of it. We can also set our criticality, if it's something important or not. We can also resolve an alert. So if maybe our monitoring tool isn't as clear, or we've got a script coming in, and maybe we're, missing, some sort of way that it usually resolves, based on the payload, right, we can come in and resolve it ourselves. We talked about transformations, and then as we'll see the results, we can also schedule automation to automatically kick off. So for example, the step before, as we'll see, I kicked off, something just to check to make sure our Kube API server was up and available.
Awesome.
Yeah. So this really covers the start of the event lifecycle, right? As this event comes into PagerDuty and this lifecycle begins, these are all the steps that PagerDuty's operation platform is going to help take, again, so that you can, have proper context, you'll have deeper insight, you'll have less noise that you're dealing with while you're in the midst of, troubleshooting incidents and outages. And finally, we're going to make sure it's getting to the right team. All that's very critical to happen up front at the start, because as you can imagine, without all of that happening, right, you're going to, as Dormain pointed out, you're digging into the alert for the data itself. Maybe you're reassigning to another team and scrambling to make sure that they know that they have an issue. Now, moving on, I'm going to dive into the incident itself a bit more, and we're going to start to take a look at what it looks like when we're in the middle of this, events life cycle. We're trying to bring things back online. Maybe we're still not sure exactly what's happening. So I've drilled down in here. I get a bit more detail. I can see who's on call. Let me go ahead and acknowledge this. For those of you who do know PagerDuty, we're relentless when it comes to reaching out to folks, right? We want to make sure they know they've got an issue. So Jackie, she was going to get a phone call. She'll get a text message. She'll get a push to our mobile app. All of that to, alert her and let her know that there's an issue. I'll go ahead and acknowledge it myself. That way we stop the process. And it's also not going to escalate up the chain. So, what we do at our core, calling out the folks, we can have multiple layers. So if someone's, out of the office or not available, again, our goal is to make sure we get someone online to help troubleshoot this issue. Now to start, we're dealing with the Kubernetes issue. So we'll talk through some of the typical, triage things that you might deal with. I'll scroll down. I actually put together a little, example troubleshooting doc when it comes to, things like a Kubernetes cluster. As we talked about, the Kube API server is one of the first things you'll want to look at. Without that, trying to run additional commands against the cluster is going to fail. We could see here on the right-hand side of my incident notes that our platform already triggered an automation to check for that. And we want to make it very simple. Green check marks for good, red X's for bad. We could dump out the raw data here in the incident. We've got an example of that. But then you still got to parse through and make heads or tails of what that data means. Here we can quickly, and easily summarize, and again, give you quicker insight, quicker context as to what's happening. And we could see here, Kube API server is healthy. So let's move on, to our next step. We've already saved ourselves some steps, and we're now, going to steps 2 and, maybe even 3 to begin this troubleshooting process. Having a run book like this, I would have loved to have something like this when I was on call. Unfortunately, we were all just trying to remember what we did the last time. But having these defined is very important, right? Gives you a repeatable process, something that your teams can work off of. And when there is an incident, they don't have to track other folks down. They can get right to work. And while having this is all good, to do this, we've usually got to leave, and I'm going to go SSH to my cluster. Maybe I've got 3 or 5 nodes I've got to hit up to run some of these commands against. I'm going to have to leave PagerDuty and lose the context that I had while I'm troubleshooting and working on this incident. But wouldn't it be great if, with the push of a button, we could just start to run some of these diagnostics commands and pull this information in automatically? So I've got a few different, options available. I'll go ahead and let's see how our system pods are doing. We can execute this. We're dynamically pulling information from the incident itself. So I'm passing along the ID. We've got other jobs that'll pull that pod name and pass that along as well. If we were interested in looking at, the specifics of my pod. But for this, we went ahead and executed. Didn't have to leave PagerDuty, and we could see here, I've got a result with the list of all my system pods and their current statuses, which is awesome. Our automation platform went out, ran the command that we had specified, gathered those results as if I was typing it myself, and then put it right here in my incident notes. Again, based on payload, that could be something that maybe we automatically trigger if it's information that we want to have. Now, this is great, but I think it could be a little better. What if I didn't have to interpret this data? If I'm new to Kubernetes, or perhaps just new to the company in general, right? Looking at some of these technical outputs can be a little unnerving. So in this case, let's look at what we can do is program our system to not only run the diagnostics one or more commands. And here we could see I'm pulling that my pod variable right from my alert payload and passing this through to execute this job. But here I've got a health check that I've started. So instead of dumping out a bunch of raw technical data that I then have to interpret, see if it's, good, bad, whatever, I can go ahead and run a health check. And now we've built this so that it's going to do those steps for us and then summarize the data in an easy to read format. Sometimes when we click on the timeline, it'll load a little quicker. But we could see here, my health check has come back. Once again, Kube API server is looking good. System pods, they look healthy. I could kind of tell that from here, right? Everything was up and running. But now I know for sure. And it looks like I've got a bit of node health issue. Okay, great. I've got a quicker context as to what's going on. I can more quickly diagnose where my specific issue is. And this is just as good as me, waking up my level 2, level 3 SME who's going to have to do this manually for me, and honestly probably give me a little gripe the next day for waking them up at 4 a.m. Instead, I can just have this automatically run and have the data stuck right here in my incident note.
Yeah, and if you're not having to figure out how to access an SSH into that system, it's kind of all wrapped in for you.
Yep, I don't need to remember usernames and passwords. I don't even need SSH keys stored locally on my machine. I haven't left PagerDuty yet, and I've already got a couple commands that I've run against my systems, and have had them report back already.
Yeah. So just in terms of having like a kind of auditable trail of who's actually been accessing these systems, and where those keys kind of stored, then this actually really improves the security posture for those Kubernetes environments too.
Oh yeah, absolutely. We could see here, right? The timeline's going to catch, who's triggering what, and when it's being triggered. And yeah, again, I don't need those username and passwords to our production systems. I've known places where everybody knows the username and password. Maybe it's the same across different machines that it shouldn't be, just so that everyone can get in when they need to, which obviously is not a best practice. So yeah, no, that's a great point. So I've got my results, I've ran my commands, I've got my health check here, and I know nodes are unhealthy, but let's assume I am brand new to this and I have no idea what to do next. I do have these buttons here, which I could run, but not too sure what they do. So I want to get some people on board to help me make sure I don't make any mistakes, but also, again, to ensure that we get this issue resolved as quickly and efficiently as possible. So some of the things that the PagerDuty Operations Cloud can help you do, you can create a conference bridge, set up a dedicated chat apps channel. So it gives you a space to collaborate with other folks, start to drill down, see what the issues are. With our bidirectional integrations with ITSM tools and chat ops, we can be sending in notes from Slack, sending in notes from ServiceNow, Jira, Teams, it doesn't matter. All of that's going to get consolidated here on our timeline. If I need additional help, I can go ahead and add folks, pull them in to help me troubleshoot. I don't need to know on-call schedules. PagerDuty is going to handle that for me. I just need to know which teams I need to get a hold of to pull in. They'll reach out to the appropriate person who's on call. And then I don't end up with some guy's number in my back pocket and I'm calling him all the time and he eventually gets burned out or, God forbid, quits answering. We can also facilitate communication to folks, not involved necessarily with the resolution, but, who may need to be informed. We've got internal status pages for folks inside of your organization who might need to be kept in the loop when systems are having an issue. They can subscribe to those different services and business services so that, they'll get status updates as they come out. We can manually subscribe folks to incidents as well. We also have an external status page. I'm not going to show any of these today, but something to keep in mind, where if you've got end users, clients who are consuming your services, and you want something public for them, where they can go and look to see if you're currently having an outage, we can help facilitate communication that way as well. Probably the most common is subscribing, these non-technical users, maybe VPs and directors. We can subscribe them to the incident, and then any status update that we send out, they'll get notified. This is outside of these notes, right? The notes are all the nitty gritty, the technical details. They don't need to see all that, right? We'll have curated content that we'll put out to our stakeholders to keep them informed of what's going along. And as we do that, we can have templates for that built. And we can also help you come up with what that status is going to be. We've got a bit of generative AI here where it'll go back in the incident, look at the notes, look at some of the details, and it's going to suggest the status update automatically for you. I've been in the situation where it seems simple to write a status update, but when you're switching context, trying to troubleshoot, your mind will go blank, and you're like, I have no idea what to write. We at least give you a suggestion here. You can obviously edit it as you see fit. But then once you send that out, folks who are subscribed, they'll get an email, they'll get a text message, maybe a push to their mobile application if they've got that installed.
And just to again, pause and double click a little, because I realize we're going through this in almost like the super slow-mo version of an incident in order to unpack all these things that are happening. Because there's a ton of bits that have already been automated, right? Like already been set up, but we're taking the time to look at them. So just in the spirit of that, what you just showed was a generative AI feature that's now in preview in the product, where that status update, just at the click of a button, you get like a drafted status update. So that sort of tyranny of the blank page. We've had a couple of the folks who worked on that underlying feature. We did some live streams with them a little while ago, but super cool, and something that we've heard customers talk about needing maybe sometimes 3 different people during a major incident just dedicated to those types of internal communications. There's a huge kind of cognitive overhead to how do you synthesize and summarize all of these things that have been happening and then write it for the appropriate audience. Is this a technical audience? Is this my sort of business VP audience? So just to unpack a little bit of that little magic wand that you waved so deftly a moment ago. But yeah, sorry, please continue. Didn't mean to interrupt too long.
Oh, no, all good. Great commentary, and definitely helped me drive the point home. So please continue. So I talked through some of these manual steps that we can take to help, mobilize, get folks on board. Would you believe me if I told you we have a way to automate that?
What?
We do. We can have it manually triggered, or it's something we can do conditionally. So just by me bumping this from a P2 to a P1, right? I saw the health check come back. I'm not quite sure what's going on. Might get in trouble for a P1, but hey, I'd rather get it solved than have an outage. So the way I've got my system set up here is just by triggering that, the system's going to automatically take all those steps that we talked about. It's going to create a conference bridge. It's going to set a dedicated chat ops channel. It's going to request additional help from folks to come into the incident. It's going to subscribe users to the incident itself, and then it's going to automatically send out a status update. And if we look in the timeline, we could see where it was started via conditional trigger. It calls out each and every step it's taking along the way. So we've got that audit history, and then let us know once that incident workflow is done. But we've done all those steps automatically and even sent out that status update to let folks know, hey, we're having an outage. Please expect to update in the next 15 minutes. And again, all I did was pump that from a P2 to a P1. So that change in priority could come from me working inside PagerDuty. That change in priority could come from an alert, higher priority alert coming in and getting grouped. It could come from someone making a change in Jira or ServiceNow and bumping the priority there. No matter where that change comes from, the moment this incident is changed to priority 1, it's going to trigger that incident workflow. So now we're extending the capabilities of the platforms that we integrate with by making things, so cohesive and connected.
Yeah, and I love how you mentioned all the different ways that can get triggered. And I think the other thing worth pointing out is, we're showing here the idea of like this got I don't know, promoted to a P1, if you will, and so it becomes this all hands on deck and create all of the different communication channels and follow-up steps. But the other use case, like I've heard about from customers, is actually this is a thing, but it's like it's actually we need to almost like de-escalate it. Like it's there, but we want to sort of automate how we handle a lot of the P3 and higher, P3, P4, P5, that just kind of chew up a lot of time. And it's actually, we just want to run certain workflows against those. And so just to kind of call out that, like, that's another scenario and use case when these workflows come in handy.
Yeah, exactly. Yeah, you could have workflows triggered if something becomes a P2, could kind of be like your first level incident workflow. Then if it gets bumped up to P1, you've got another one that's more intense and, more broad scope. So yeah, you could certainly have, all those different levels configured with your different workflows. Absolutely. So, yeah, so we've seen how PagerDuty, how our operations cloud, can help you in the middle of your event lifecycle, especially here with Kubernetes. We were able to see how we can automatically trigger things to happen when the events come in. We can manually trigger with the push of a button actions that would usually require us to, log into a server, SSH, maybe to multiple nodes. All of that can be automated. And then we saw the difference between, basic output where we're just dumping that raw technical data and the advantage of having it summarized with, easy to read symbols, green check marks, healthy, unhealthy. And then we saw, if I do need a human involved, maybe my automation didn't fix that. We've got all the different options for pulling folks in. And again, doing it in an efficient and effective manner so that we can get this incident resolved as quickly as possible. Now, in the interest of time, I do have a few more things to show everyone. So let's go ahead and assume that Don here is my troubleshooting guru today, and let me know that he went ahead and restarted the system, restarted one of the nodes that was unhealthy, and thankfully that fixed our issue. Yay! Good job, Don. Appreciate the help. Um, so now, we'll go ahead and this starts to get to the end of this life cycle of the event. Now that this incident is resolved, what are we going to do? When we do resolve here, again, we can send another status update. This resolution note will be included as part of that. So again, we're constantly keeping those who need to know. That we're at the end of this life cycle, I've got another magic wand to wave in the form of generative AI. Before we had the same kind of blank slate problem where when you would create a post-mortem, at kind of summary of what happened after action, it would be blank, right? You'd fill in the summary, kind of what happened during the incident, what were the results. We did, have the timeline there for you. You'd have to manually click what you wanted. Saved you time, right? Still better than going to 3 different tools, Excel sheets, digging in Slack to form that timeline. But we thought, there's probably a way to do this better. And, leveraging generative AI with their large language models, they're very good at, reading large amounts of text and summarizing that data for us. Much like we did for the status update, we're going to do the exact same thing for generating a draft of your postmortem. So you'll have time to go back in and actually, make edits, make tweaks. But we're going to take that first pass. We're going to summarize the data for you, call out what happened during the incident, and then we're going to take a shot at what the timeline would look like, right? What are the most critical things to include as part of that? And sometimes when you run these, you will have a slight issue where it won't generate, but then you can always run it again. And again, the idea here is that we want to save you time, right? You've already probably fried from having to do the incident, or maybe it's a different team that wasn't there, right? They don't necessarily have all the context. So it could be a little cumbersome to go back and even using our tool, right, manually build it out. So what we've done here with, generative AI, again, taken all that information from the incident itself, looked at the timeline updates, and we've gone ahead and created a draft post-mortem for you to use. Now you can come in and edit this as you see fit, but as you can see, coming in. I've got my Slack channel pulled in, doing all the different summary data. This could take quite a bit of time. So we've gone ahead and done that for you. And then again, you can edit this, as you see fit. But the most important thing is that this information gets fed into your, problem management process. So what are you doing after the fact? So having these postmortems is a big part of that. So now that we've got this information here, what do we want to do with it? We're going to want to feed this back into our teams. We're going to want to use the, detailed info around the alerts. Maybe we need to update some event rules if we want to handle things slightly differently based on this more specific event that we've come across. We think about all the automations that we had run, right? If there's, a few more that maybe we need to add into the toolbox based on the incident that we've got here, we could start to feed that into our automation platform. There in our automation platform, I don't have it for demo today, but we're working with generative AI there as well. Again, to solve that blank slate problem. Our automation platform is very powerful because you can do a lot with it, but that means you're kind of building it from the ground up to meet your needs. Same thing. We could take our learnings here. Let's take this, feed it into our generative AI for runbooks, create automations that now we can trigger through event orchestration so that hopefully the next time we see an event like this, we can automatically take those steps that we need, do the diagnostics automatically, interpret that, translate it into some remediation steps that we want to take, and ultimately solve the issue without ever having to get anyone online. So I've got a little demo. It's the last thing here at the end, where we're going to send another event in and see what it looks like to have that event be automatically handled from the beginning all the way through resolution. So I'll go ahead and
is this the buckle up, folks, and get ready? Okay. All right. Please
buckle.
check
It does go fast too. That's the only other challenge with doing it this way. The system's much quicker than all the time I just took to walk through there.
Yeah. Well, good. Now everyone knows what they're looking for. So please bring your seat backs up and your tray tables put away. We're getting ready to land this plane. So you're going to send in just a new alert, and we're going to go all the way back to the beginning where all the alerts are getting kind of processed, aggregated, correlated, and sort of those enrichment steps are being followed. Just to kind of walk people through what they're going to see again, and then those automated actions get taken. Is the Kube API alive? Yes or no? So that responder has so much more context at their fingertips. Oh, Corbin, I can't hear you all of a sudden.
Can you hear me now?
Yes, you're back.
Okay, perfect. Yeah, so you hit the nail on the head. So yeah, we're going all the way back to the beginning. I've generated a new alert. The first thing to notice is I did a low urgency. So same thing we saw before that was high urgency. Now I've got it categorized as low because I've seen this before and I know I can potentially handle this with automation because I took my learnings from my postmortem and fed them back into my event orchestration as well as my automation platform. And while I was talking, that all went through. I should have been more focused on what was happening here, but it came in as a low. First thing we did is PagerDuty automation acknowledged. So we're not going to page out to a human. We're going to let automation take a first stab at attempting to solve this. So we acknowledge the event, which stops that escalation process. We can keep that in place so that if for some reason our automation doesn't work, in 5-10 minutes, whatever we've got it set to, if it hasn't acknowledged, well, now we're going to reach out to a human because maybe there's something wrong with our automation. It's come in, added a note to let us know it's going to run that health check. So it ran it automatically. I didn't have to come in. This is what I manually clicked my button before. It could see, hey, we've got some issues with the nodes themselves, so we'll go ahead and attempt to restart the services on our impacted nodes. If we recall, that was what Don had done manually before to solve our issue. After that runs, it can check to confirm services are back online. We'll rerun the health check. We see here comes back. Now we're all green. So we've got confirmation that what we tried did in fact work. We can make a note of the health check being good, and then PagerDuty automation is going to automatically resolve that. So all of that happened, through event orchestration, through being triggered based on the alert payload. And then, we're keeping all that information updated here in the timeline so that as you go back, right, we can run a post-mortem on this just like before. The only difference is we didn't have any humans involved. So we were able to get this solved without using, PagerDuty, what we're known for, which is our on-call. We did that without any on-call, without notifying anyone. Now, the beauty here, as I said, if all of this runs and that health check came back not clean and we still had an issue, we can always fall back, call, text, mobile push update, get someone online to help solve the issue. The difference is they'll see all the steps that our automation has taken leading up to that, so they'll know what's already been tried and what didn't work, which is again going to give them deeper insight and quicker context to more quickly solve this issue and make sure it doesn't become a larger incident.
Amazing. And like, look at that. The whole time was like 1 minute. If you the timeline, you can see the timestamps on all of those.
Yeah.
This is what we're talking about. Self-resolving incidents at machine speed. And so you're not having to even wait on the humans, and you're letting the humans either keep sleeping or focusing on the more important work. So thank you, Corbin. That was a beautiful landing. If we were on a plane, this is the part where all the passengers applaud. Any last closing parts of the demo you want to show us, or is this it?
No, this is what I had for everyone today. Hopefully, it made sense. It was relevant. You got to learn a little something about PagerDuty, and especially how our Operations Cloud can help you when you're dealing with all the events that are flowing in from your Kubernetes environment.
Yeah, absolutely. I love how a lot of Kubernetes best practices are getting worked in there, and then that can really scale out to the team. And again, just the chef's kiss on a self-resolving incident at the end. Love it. Thank you so much, Corbin. Thanks everyone for tuning in. We'll have the replay here on LinkedIn, as well as we'll have it over on YouTube. So stay tuned. We'll have more demo showcases and Roundup, maybe with a cowboy hat next time. We'll see. And have a great, wonderful, uneventful rest of your day.
Thanks, everyone.